So, review of exponent laws. Powers are comprised of a base and an exponent. So we're looking at a power, right? We've got the base, which is A, the exponent, which is N. Radicals are composed of a radicand, an index sign, and a radical sign. Okay, so radicand, that's the thing we're taking the root of. The index is which root we're taking, and the radical sign is, we usually call it the square root sign, but if you put a 3 in there or something, then it's actually a cube root. So here are the exponent laws. You've seen these before, right? So a to the m times a to the n. When you multiply powers with the same base, you add the exponents. So it'll be a to the power of m plus n. 3 squared times 3 to the 4th is 3 to the 2 plus 4, which is 3 to the 6. And if we generalize that even further, get into some algebraic stuff, 3 to the x times 3 to the 4 minus 2x is x plus 4 minus 2x. Now, anytime you get a binomial up here, put it in brackets, okay? And then remove the signs. In this case, a plus sign, nothing really changes. So it's 3, actually, let me move this over here. 3 to the x plus 4 minus 2x, which is 3 to the negative x plus 4. Okay, just adding x minus 2x gives you negative x, then plus 4. Okay, so that's product of powers. Quotient of powers. When we're multiplying powers with the same base, we subtract the exponents. So if you just came in as the back of the purple sheet. Okay. So 6 to the 8 divided by 6 to the 2 is 6 to the 8 minus 2, which is 6 to the 6. Dividing, this will be 6 to the 8x squared minus 2x, and really that's all you do, right? There's nothing else. We can't simplify that. We have a squared term and an x term. Power of a power. When you have a power to a power, you multiply the exponent, so it's a to the m times n. This is 3 to the 2 times 4, or 3 to the 8. And this is 3 to the 2 times 4 plus x. And again, we have a binomial. Anytime you see a binomial, put brackets around it. Okay, multiply and then go multiply. So it's 3, and we use distributive law. So it'll be 8 plus 2x. Okay, now, don't worry about any of this stuff. We're going to go back through a lot of it. Well, not so much this stuff. This is review of previous. Power of a product. If you have a power of a product, then you take each individual part and raise it to the power. So it's a to the m, b to the m. 2 times 3 cubed could be written as 2 cubed times 3 cubed. Could also be written as 6 cubed, right? These two, we can't multiply. We can work these up. You can't just multiply that and say that it's 6. It just happens to be, well, you can, but you'd have to sort of back it up to here and then to here. Anyway, this 2 times x to the 4th is 2 to the 4th x to the 4th. Okay. Biggest thing, the thing most people most often forget is they'll raise the x to the 4th because you're kind of used to raising a power, but you won't raise the 2 to the 4th. So. Power of a quotient, as long as b isn't 0, because we know can't divide by 0, right? Restrictions. It's just a to the m over b to the m. And that's 3 cubed over 4 cubed. And this one is x cubed over 4 cubed. 0 exponent, anything to a 0 exponent is 1. Well, anything but 0. 6 plus 1 to the 0 is 1. X squared plus 1 to the 0 is 1. Okay, so even if you have a more complicated expression, if it's raised to the exponent 0, the result is just 1. Negative exponent means 1 over, so it's 1 over a to the positive n. So we make that exponent positive, but the power moves to the denominator, right? It becomes 1 over. 5 to the negative 2 is 1 over 5 squared. x to the negative 2 is 1 over x squared. A fractional exponent, the bottom number of the fraction is the root. And you can also write this like this. So you take the nth root of a, the bottom number is what root, like I can take the cube root here. I take the cube root of a, and then I'm going to raise it to the power of m. That would be this, or you can raise a to the power of m and then do the root. So if we look at 9 to the 3/2, it's the square root of 9, and then you cube that. Now that you can do without a calculator, because we know the square root of 9 is 3, and that'll give us 27. Otherwise, we can also look at this as the square root of 9 cubed, right? That's harder to do in your head, because it's not really easy to cube the 9, right? And you can also just plug this into your calculator, 9 to the power of 3/2, and you'll get out 27. 9x to the 3/2 will be 9 to the 3/2. Well, let's say it would be the square root of 9x to the power of 3. So you don't really need this 2 here, right, as an index. If we leave the 2 out, then we know that it's a square root. Okay, so first page. So review of power laws, what's power and all that stuff. We're not going to go through and do a bunch. I'm basically just going to do them, and you can just sort of copy it out, okay? Don't worry, because as we go through the unit, we're going to go back over. We just had an extra day, so we're just taking a day to just kind of go through this and get you in the mood. So it's p to the 10 plus 4 over p to the 11. It's p to the 14 over p to the 11. Okay, so we're using power rule up top, right? We're multiplying powers with the same base. We add the exponents. Now I have a quotient, 14 over 11. Quotient says when you have powers with the same base, you're dividing. You subtract the exponents, and 14 minus 11 is 3. 6 divided by negative 48, so we get negative 8. Actually, let's just do this down here. Okay, so negative 48 divided by 6 is negative 8. D to the 5th divided by d to the negative 2 is d to the 5 minus negative 2. Subtracting a negative, you add a positive, so it becomes 5 plus 2, and we get negative 8 d to the 7th. Here we're multiplying 5 times negative 2, so we just multiply the numbers normally. I'm multiplying the exponents, right? So the powers, they have the same base, they're both x, so I add the exponents. So I'm going to add 3/2 plus 5/2. So that's 8/2, and 8/2 is just 4. Okay, so all you're doing today really is just kind of copying this down, watching, just sort of saying, yeah, I've seen some of that stuff, or I don't remember that, right? Oh, you don't need to comprehend. We're not comprehending today. Oh, copy it down. Okay, you copy it down. Sorry, like Katie says, I always go too fast.
Yeah, no, that's what she's doing.
The video I played for the calculus students was like, stuff calculus students would never say. It's like, can you go through the example faster? Can you skip some more steps? So think of this stuff is just kind of reference for you to look back at, right? Example, so if you're looking at something, you say, hey, we did something similar to that. How did we do it? That's what this stuff is. Okay, ready? Move it. power to a power, so it's going to be 5 to the negative 2, p to the 4 times negative 2. What's the exponent on the 5 in here? Okay, if you don't see an exponent, it's a 1. Okay, so we go 1 times negative 2, which is negative 2. So 5 to the negative 2 is, well, let's just leave this as 5 to the negative 2. This will be p to the negative 8. So I have negative exponents. I need to make them positive. So we move them, right? Now, in essence, they're up top. I mean, there is no top or bottom here, but they're on the top. So I'm going to move them down. It'll be 5 squared, p to the positive 8. So now they become positive power. And 5 squared is 25. We get 1 over 25 p to the 8. When you raise a negative to an even power, it becomes a positive. Yep.
On the first step, is that 4 times negative 2?
4 times negative 2, yeah. It's power to a power, so we multiply exponents. This one is also power to a power, so we've got negative 2 to the 6th, and then x to the 3/2 times 6. Now, if I'm multiplying by 6, I'm going to write it as 6 over 1, right? Because it's like multiplying fraction. And it's nicer if I have a numerator and denominator, and I can say 2 goes into 6 3 times. So negative 2 to the 6th is a positive, right? Because you got negatives pairing up, right? We got 2 negatives that pair up, and then another 2 and another 2. So that's just 2 to the 6th, which is 64. And then this is x to the 9th. So 3/2 times 6, 1.5 times 6 is 9. Okay, over here, we have to do this first, right? It's like order of operations, right? You do the brackets. That has to be cubed. When you cube a negative, you get a negative. So it'll be negative 4 cubed, a to the negative 2 times 3. And then 8a to the 7th. So negative 4 cubed is negative 4 times negative 4, which is positive 16, times negative 4, which will be negative 64. A to the negative 6, and I guess these are all being multiplied, times 8a to the 7th. So now we can multiply the numbers. Negative 64 times 8, these really need little equal signs, is negative 512. A to the negative 6 times a to the 7. So we get a, negative 6 plus 7. Okay, multiplying powers, add the exponents. You get negative 512a. You are probably not going to see anything anywhere near like some of these. Okay, but it doesn't hurt to be exposed to them. Because you might get 1 or 2. Right, you might see 1 or 2 tough ones. Generally speaking, stuff's going to be pretty, fairly basic, but there could be a couple more challenging ones. And you can look back at these and say, okay, I saw something like that. What does it look like? Right. And I'll put all these, I'll save this as a PDF and put it up. And then I'm also recording this because we didn't do it before, and I'll put it up, and it'll be at the top of the exponential functions folder in 30-2. Okay, we got it all? Looks like. Evaluate each of the following without a calculator by converting each to radical form and then simplifying. Stuff, this is out of 10C, right? Converting roots and powers and that. So 16 to the half is the square root of 16, which is 4. 64 to the negative 1/2, we can't do negative exponents, but we can change it to positive. So it becomes 1 over 64 to the positive half. Converting that to a radical, it's 1 over square root 64. And the square root of 64 is 8. $1.25 to the 1/3. So again, we want to convert to radical. It says convert each to a radical form. So remember, the bottom number is what root? And the top number is what power? So it's the cube root of 125, which is 5, right? Now you can always use your calculator, right? We're never taking your calculators away from you, so you can use your calculator to do any of these. But you know, some of the things we do here are going to come in, you know, when we do like solving exponential equations. We're going to do some of that. We'll be using some of this stuff. Okay. 27, the negative 2/3 is 1 over 27 to the 2/3. So we need to change a negative power to positive power. We do that by moving it to the denominator. So it would be the cube root of 27. Now I could put a squared on the 27, but that's a little harder to work out without a calculator. So it's 1 over 27 to the positive 2/3. The 3 tells me I'm taking a cube root, so it's the cube root of 27. And the 2 says, what are you doing with that? I'm going to square that. So it's 1 over 3 squared, which is 1 over 9. Okay, I'll give you a chance. We got a few more on this page, and then okay, again, don't worry about this. This is the preview, right? We're going to go back through all of this. Anything we do here, we're going to go back through again. Concentrating more on the stuff that you need to know, right? Some of this goes a little bit beyond just sort of review of 10C stuff and that. Okay, so we've got a product of a power, so that's 16 to the 1/2, and x to the 4 times 1/2. So I'm going to write the 4 as a 4 over 1. Actually, I'll clean that up a bit. That's times. So it's square root 16. And then we've got an x, and that's 4 over 2, so x squared. So it becomes 4x squared. Okay, so that's power of a product, right? You take each individual part. The product is 16 times, that's the product, x to the 4th. So we take each one individually. It's 16 to the 1/2. Remember, 16 is 16 to the power of 1. Okay, so we've got this. Now, there's something fancy we can do with this. If you have a negative exponent, you can turn it positive if you flip, just take the reciprocal, if it's a quotient, right? So if it's a quotient, 64 over x squared, and I want a negative 1/2, I can turn the negative half to a positive by flipping it, right? That just moves stuff where it wasn't. If it was up top, it's now in the denominator. And then we get x squared times 1/2 over 64 to the 1/2. Okay, then it's quotient to a power, which means we raise each part of the quotient. The top, the numerator gets raised to the power of a half, the denominator to a power of a half. Change it to radical. This is just like E. So it's 125 to the 1/3, x to the 6 times 1/3. Okay, power of 1/3 is a cube root. Okay, and then we're not raising it to any power after that, right? We're taking the cube root, but we're not doing any power. 6 over 3 is 2. Cube root of 125 is 5. we get 5x squared. This is negative, but it's not a quotient. So we write it as 1 over. Whoops, that should be positive 2/3. Okay, so it's 1 over 27x to the 9th to the positive 2/3. So it's 1 over 27 to the 2/3, x to the 9 times 2/3. And whenever I'm doing one of these multiplying by a fraction, then I write the 9 as like 9 over 1, so I can keep it straight, right, as numerator, denominator. So cube root of 27 squared, right? Again, the bottom number says take the cube root of 27, and then do what? Then square it. 9 times 2 is 18, divided by 3 is 6. We already did this cube root of 27, right? So that's, whoops. So that's 1 over 3 squared x to the 6th, or 1 over 9 x to the 6th. Okay, so again, remember, this is just a preview, right? No homework on this. I'm not going to ask you to do a bunch of these. We're just going to, again, when we get into the unit, we're going to go back. We'll be hitting this stuff again, and you'll at least have seen it this once, and you'll say, okay, you know, right, we saw what this was. Express each of the following as a power. So it's changing a radical to an exponential. So a square root is 1/2. It's a cube root. The root is the denominator of the fraction. You raise it to a fractional power, and then you're squaring it. So what root goes on the bottom? What power? I'm squaring the 5. That goes up top. Okay, we're changing that radical, 4th root, so the 4 goes on the bottom of x cubed, so the 3 goes up top. So it's 5x over x to the 3/4. I'm dividing powers with the same base, so I subtract the exponents. There's no number. If there's no number, it's a 1, right? So I got 1 minus 3/4. And 1 minus 3/4 is 1/4. Oh, running out of sheet already. Okay. That's good. Write each of the following as a single power with a base of 2 or 3. Okay, this actually will happen. We are going to have to do this in the unit, but again, we're just previewing this now. So we're saying each of those numbers can be written as either a power of 2 or a power of 3. So 32, is that a power of 2 or a power of 3? 2. So I always just use my fingers, right? I go 2, 4, 8, 16, 32, right? So 32 is 2 to the power of 5. Okay, now you can use your calculators, right? So you can just sit there and go 32, I think it's a power of 2, is it like 2 to the 4th? No, it's too small. So 2 to the 6th, too big, right? So you come upon the answer. 2 cubed times 4 to the x. So what we want to do is we want to write 4 as a power of 2. How do we write 4 as a power of 2? Take one of each of those. Purple and one next one. So what's 4? 2 squared. So I'm replacing the 4 with a 2 squared, right? But there's still that x there, so that x is up here. Okay, so we rewrote 4. We wrote it as 2 squared. But the 4 is raised to the x, so does the 2 squared have to be. So this is 2 cubed. Now this is power to a power, so we've got to multiply the powers, right? So instead of 4 to the x, we have 2 to the power of 2x. Now what do we do with these two numbers? We add them. Okay, so we will see this again. We're going to use this when we solve exponential equations. Okay, where we're going to have to change one number into writing it as a power of a different number. Okay, well, 16 and 8, they're both powers of 2, right? Because we counted them up, 2, 4, 8, 16, 32. So 16, 2, 4, 8, 16, so that's 2 to the 4th. So I'm going to write this as 2 to the 4th, and then that's going to be raised to the power of 3/4, right? So instead of 16, we're writing an equivalent expression, but as a power of 2, right? So we're saying it's 2 to the 4th. 8. Eight can be written as 2 cubed, right? So we're going to replace the 8 by 2 cubed. And then that has to be cubed, right? So if you look, you're just seeing, okay, instead of 16, like you got something to the 3/4 here and something to the 3/4 here. These two somethings are the same. One is 16, one is 2 to the 4th. You got 8, and here you got 2 cubed. Okay, well, we can work with this. We do 4 times 3/4. So we have 4 over 1 times 3 over 4. Okay, now this can be written as 2 to the power of 3/2, right? So we're going to take the radical out. Remember, change it to exponential form. What, excuse me, what root? Square root. Square root, oh, the root goes on the bottom as a 2. Okay, but remember, that's cubed. So the root 8 changed to a root of 2 cubed, changed to a 2 to the 3/2, right? Which is the square root of 2 cubed. And then that's being cubed. 4 over 1 times 3 over 4 is just 3, so that's 2 cubed. This will be 2 to the 9 over 2. Okay, so I actually skipped a step there, but right, it's 3/2 times 3. Okay, if you like, right, this is 3 over 1. Just say I'm multiplying, right? Power to a power, I have to multiply the exponents. Okay, well, we can keep going because we're multiplying powers with the same base, so we get to add the exponents. In order to add to a fraction, I need a common denominator. Right, so 3 becomes 6 over 2, right? Equivalent rational expression. I think on the test, which is kind of half marked, you did pretty well on the equivalent rational expression stuff. But when I get them marked, I'll send out a text or remind 101 and just say your marks are up.
Have you sent any since I signed up? Because I haven't got one.
Since you sign up, maybe not. You probably get one later today or tonight or tomorrow. Keep in mind, rational expressions, we're talking maybe 5 questions on the diploma, right? So I mean, you look at the test and you go, well, I didn't really do well on the test. It's okay. It's one unit, right? There's a lot of different units. Okay, next one. 1/2 to the x and 64. So if we want to write 1/2, we can write 1/2 as 2 to the negative 1. Okay, so we don't write a half, we write 2 to the power of negative 1. We want to express things, and then that's raised to the power of x times 64, okay, 2, 4, 8, 16, 32, 64, so that's 6, 2 to the 6th. To the x minus 3. Okay, we got power to a power. This is 2 to the negative x, right? You just have negative 1 times x. And we got power to a power here again, times 2. This will be 6 times x minus 3. So it's a binomial. Remember to put it in brackets. Right? That's a big thing. That's a skill you're gonna need in exponents and logs, is just remembering that, hey, if I'm multiplying by a binomial. So we've got negative x. This is 6x minus 18. Okay. Now, we're multiplying powers with the same base. We add the exponent, so it's 2 to the negative x plus 6x minus 18. And negative x plus 6x is 5x minus 18. Okay? You will never see anything like this other than here. All right? You need stuff where parts of this will come in, but the whole thing together, you're not going to see that in the course. All right, so I'll give you a moment. The 2 powers of 3. So 1 over 27 is equal to 1 over 3 cubed. And you could write that as 3 to the negative 3. Right? So you want to be familiar with your powers of 2, 2, 4, 8, 16, 32, 64, 128. Your powers of 3, 3, 9, 27, 81, 243. Usually, mainly it's like 3, 9, 27, 81. And you know, here, okay, 243. So 243 is 3 to the 5th, right? Now, if you don't know that, you can just sit there and play with powers of 3, right? You go 3 to the 4th, no, too small. 3 to the 5th, yeah, oh, that's it. So this is 3 to the 5th. So we're just doing exactly what we did on the previous set, only this time it's 3, powers of 3 instead of powers of 2. Okay, remember, you're going to do multiply, treat that as a binomial in brackets, go 5x minus 10. Okay, so that's an important skill. The reason why we want to change, I mean, here it's not a big deal. Like, why does it matter if it's a power of 3? Here, it matters if it's power 3 because then when the bases are the same, we can simplify the expression. Okay? So that's really the takeaway concept here is when I get the bases the same, then I can simplify the expression, right? Even if we're doing sort of more complicated stuff. So 9 is 3 squared. Okay. So you're going to look at things and you're going to see a mixture of 3s and 9s and 27s and say, if I write them all with the same base, a base of 3, then I can use my exponent laws. And this unit's called exponential function, so it's based around the exponent laws, right? And then the next one is logarithmic function, which is also based. So up top, exponent law is power to a power. So you multiply. We have a quotient. When you have a quotient, you subtract. When you're subtracting a binomial, you make sure that this is in brackets. Okay, so you'll go minus x minus 1. So removing the brackets, we get minus 2x minus x minus 1. And now we can collect. And that's our simplified form. Okay, again, you're gonna be seeing the same concept, but it's gonna be at, you'll see it'll be at an easier level when we get to that part of the book. So it doesn't hurt to see this because you won't see anything worse than this, like harder than this. It should all be. Okay, so first step, you look at the 81, you use your fingers and you count it out, 3, 9, 27, 81, or you go 81 to the power of 3, I think it is, right? And you try 3 squared and 3 cubed and 3 to the 4th, and you get it there. Okay, I found the 81. Well, you can make that from a positive exponent, but in the denominator where we don't want it, I can't really do much with the power laws if it's sitting in the denominator, right? So I can move it back up by changing it to a negative exponent. So 3 to the negative 4, 1 over 3 to the 4th, same thing. So if I see a 3 to the 4th down here, I don't want this down here. I want to get it up top, then I make the exponent negative. Because now we can multiply, right? We've got power to a power. So this now becomes negative 8x. Now we have powers with the same base. See, here we didn't, right? We had this 1 over 81. But now we've got powers with the same base. We can just add these exponents. And simplify, we get x minus 8x is negative 7x, and then minus 5. Okay, so I know we're pounding through these and it's just, kind of head spinning a bit, but remember, everything we do here, we're just going to look at again, right? We'll be looking at again, so. Good. So, let's not even bother with these. Yeah, like seriously, you're not gonna see. We can bother with this.
No.
Okay, so here, just say, yeah, we're not gonna bother with those. Right? You will not see stuff like that. You will see stuff like this though. State the value or values of x. So if x squared is 9, then x is actually positive 3 or negative 3. Whenever you're taking an even root, then you get a positive number or a negative number. Now, that's not to be confused with this. If I say the square root of 9, that's just equal to positive 3, because this symbol means the positive or principal, just another word for it, the positive or principal square root. But if we say, hey, something that's being squared is going to give you 9, what is that thing? Then you say, well, it could be positive 3, but it could also be negative 3. And then we deal with context of the question too. Well, is this a quadratic that I had to solve, and do I need to reject a negative value? Like, no, you can't have a negative quantity here or something. That can't be a negative speed. X cubed is equal to 8, so then x is equal to 2. Right? Now, here's kind of how you do it. You say, I want to get this exponent to be a 1. Well, I can do that if I multiply it by a third. Put that down there. So I'll take x cubed to the power of 1/3. Well, if I take one side and raise it to the power of a third, I have to do the same thing to the other side. Now, power laws say 3 times 1/3, which is x, and this is cube root of 8, which gives you x is equal to 2. So that's kind of a little something that's going on there, right? Is, well, how am I solving for that, right? I mean, we just know what cubed is 8. Well, or what's the cube root of 8? Okay, but this is kind of what's happening in order to get that. Because how do we solve this x to the 3/2? What you want to do is you raise it to the reciprocal power, right? In other words, you flip the number over. So I'm going to take x to the 3/2, but raise it to the power of, flip that, 2/3. Now if I do that, I have to do the same thing to the other side. So it's 27 to the 2/3. So power to power. What's 3/2 times 2/3? It's just 1, right? 6/6. And what's 27 to the 2/3? Well, it's the cube root of 27 squared. Right? Now you could actually just punch 27 to the 2/3 into your calculator and get the answer, right? Which is 9. Okay, but that's how you solve that, right? And we do the same thing here. We got x to the 2/3. I'm going to raise it to the power of 3/2, right? The reciprocal power. So when I multiply them, I'm going to get 6/6, which is 1. Well, if I raise 1/2 to the 3/2, or sorry, one side to the 3/2, I have to do the same thing to the other side. Okay, so we got 16 to the 3/2. What's that mean? The square root of 16. Cubed. The square root of 16 is 4. Cubed is 64. Okay, we got x to the 2/5. What power do we have to raise it to? 5/2. Whatever you do to one side of an equation, you do to the other side. Power to a power, 2/5, that's 10/10, so that just gives you 1x. Square root of 4 to the power 5. 2 to the 5th. And we get 32. I think we'll just skip the next bunch too. Next, but they just have negative past. Yeah, well, actually,
No, we're good.
you know, let's just do B, because there's a concept here that you need. So when I go to solve this, okay, we know how to do it, right? I got to get the x to the 3/2. I need to get rid of this 2 first. So I need to divide both sides by 2 and get x to the 3/2 is equal to 64. Okay, so that's the key there, is that when you're going to do that thing of, hey, I'm going to multiply, I'm going to take both sides and raise them to the power of 2/3, you can't do it when there's a 2 there, so you need to get rid of that 2. Okay, now we can do it, and this will happen fairly quickly. Okay, and we get x equals 16. But big picture, big picture concept there is, before you do one of these things of I'm going to solve for the x's, you need to isolate the x. Okay, same thing would happen here, is I would divide both sides by 125, but we're not going to do this. graphs of exponential functions. So we're going to cover this again on Monday out of the textbook. This is just a preview. So an exponential function involves a power where the variable is part of the exponent. The basic exponential function is y is equal to c to the power of x, where c is a constant and c is greater than 0. So it could be 2 to the x, 3 to the x, 5 to the x, 1/2 to the x. So circle the functions that are classified as exponential functions. So this has a power, which is x. This doesn't. It's got a power of 5. This has a power, which is x. This has to be a constant, not a variable, and also that's a variable there too. This is a constant raised to a power, so that's exponential, and this is a constant raised to a power. Okay, so what we're going to do is we're going to see the variable in the exponent. That's what makes it an exponential function, is that the variable is the exponent. So we're just going to graph a couple. We're going to fill in a little table of values. We're going to graph this. For the exponential functions, y equals 2 to the x and 4 to the x. Complete the table of values below and sketch the graphs on the grid shown. So I'm going to shrink this a bit so that it'll fit. That's fairly decent. So 2 to the power of x. Okay, let's start with 3. What's 2 to the power of 3? 2 cubed. 8. What's 2 squared? What's 2 to the 1? What's 2 to the 0? What's anything to the 0? No, it's 1. What's 2 to the negative 1? So I'm going 8, 4, 2, 1, 1/2, 1/4, 1/8. Remember your negatives? So 2 to the negative 3 is 1 over 2 cubed is 1 over 8. Here, let's do our powers of 4 here. 4 squared is 16. 4 to the 1 is 4. 4 to the power of 1/2. Okay, well wait, power of a half is square root, right? Square root of 4 is 2. 4 to the 0, that's just 1. 4 to the negative 1/2, that's 1 over 4 to the half, or 1 over the square root of 4, so that's 1/2. 4 to the negative 1 is 1 over 4, and 4 to the negative 2 is 1 over 4 squared, or 1 over 16. Okay, so let's plot these. I'm just going to use 2 different colors here. I'll use the purple for this. So negative 3 is 1/8. It's just going to be kind of small there. Negative 2 is 1/4. Negative 1 is 1/2. 0 is 1. 1 is 2. 2 is 4. 3 is 8. And I could keep going, right? 4 would be 16, right? 2 to the 4th is 16, just powers of 2. We draw this as a smooth curve. We put arrows on both ends to indicate that it keeps going both ways, right? I mean, there is a 2 to the power 5, it's up there, and 2 to the 6th, and so on. So at the same time, we're also going to graph 4 to the x. So negative 2 is 1/60. That's like way below there. And 1/4 is, that was 1/2. This is 1/4. And negative 1/2, it's 1/2. So that's there. At 0, it's 1. Those 2 points are on top. At 1/2, it's 2. And then it's 4. And then at 2, it's 16. We can see the red graph climbs higher, but also drops lower. It climbs faster when it's to the right of the y-axis, right? When the x values are above 0, it's climbing faster, and when they're below 0, it's dropping faster. Okay, here, let's just label these guys. That's 4 to the x. And this is y equals 2 to the x. Yeah, we'll do 3 to the x in green. Where would I draw the green line over here? Would it be above the red, between the red and the purple, or below the? Between, right? 'Cause we got 2 and 4. So we know that at 1 you're going to get 3. So 3 to the x is in between. How about on the left side? Is it between them or? Still going to be between, right? It's going to drop, but it won't drop as fast as 4 to the x. Remember, 4 to the negative 1 is 1/4. 3 to the negative 1 is 1/3. So it's just going to go in between. Let's say we do 5 to the x in blue. So to the right here, where would I draw the blue line? In between red and green, in between green and purple, below purple, above red? Above red, right? Because it's going to climb faster. So we know that at 1, it's going to be 5. Okay, so there's y equals 5 to the x. And then how about as I go to the left? Is it going to be above these guys, below all of them? Below, right? Because it's going to drop faster. Okay, now, the one thing it doesn't do is it doesn't go negative, right? It just, so none of these go below 0. Okay, there's no value of x you can put in there that's going to make an exponential function go below 0. It'll get really, really small, but it can't go to 0 and it can't go negative. Okay, so that's a couple of functions. So what do we see from this? For y equals c, where c is greater than 1, and c is the base, as the value of the base c, the base of the exponential function, I think in the book they're going to call it b, increases, the graph gets, so as c increases, the graph gets what? So this was 2, 3, 4, 5. So as the value of the base is increasing, the graph is getting steeper, right? It's climbing faster, right? So it's getting steeper. Whoops. That's what I wanted. The graph gets steeper. Complete the following statements. For y equals 2 to the x, every increase of 1 unit for x corresponds to the y value blank or increasing by. So what's happening? We go from, if you look at the table, as x goes from 1 to 2, y goes from 2 to 4. As x goes from 2 to 3, y goes from 4 to 8. So what's the y value doing every time we increase x by 1? It's doubling. Yeah. Or increasing by 200%. For y equals 3 to the x, every increase of 1 unit for the x value corresponds to the y value. So it's not going to double, it's going to triple. You spelled tripling. It's not underlined in red. It must be spelled right. I don't know. Tripling's a word. Is it spelled right?
Nope, not a word.
It's a word.
Nope, not in the dictionary.
It may not be spelled right, but it's a word. Basic exponential function where c, the base, which I think when we do, we're going to call it b, but is between 0 and 1. So we're going to do 1/2 to the power of x and 1/4 to the power of x. And we'll take this down to a page so we can see the page. So let's start at 0. 1/2 to the 0, really anything to the power of 0 is 1. 1/2 to the 1 will just be 1/2. 1/2 squared is 1/2 times 1/2, which is 1/4. Half cubed is 1/2 times a half times a half, or 1/8. Half to the negative 1. Well, 1/2 to the negative 1 is, remember we can flip it over. So if that's a negative exponent, we can just, but that's a quotient we flip, so it's 2 to the 1. So half to the negative 1 is 2. And this is 4, and this is 8. And then I'll fill this one in. So 0 is 1, that's 1/4, that's 1/16, it's going to be 1/2, it's going to be 4, that's going to be 16, that's going to be 2. So we could work out each of these, right, but time is ticking. And we want to sketch the grid, or sketch the graphs, right? So at -3, I have +8. At -2, I have +4. At -1, I have +2. And here I have 1, and then it starts getting smaller. We've got a half, and a quarter, and an 8. That's y equals 1/2 to the x. Okay, then we'll plot the red graph. So -2, it's +16. And -1, it's 4. And it goes down pretty quick. Okay, so where would a third go? Below, in between, or above? In between, right? Yeah, in between. And where would a fifth go? To the left, in between, or to the right of the red? So it's kind of the same, it's just kind of opposite, right? I mean, where the ones are climbing up to the left, these guys are climbing up to the right. And where the, when c is greater than 1, as we go negative, it's falling down, and c is greater than 1, it's coming up. So these guys start high and they go low, right? Or they're going from quadrant 2 to quadrant 1 decreasing. We'll get into that on Monday, right? We're going to come back and revisit these graphs, and we'll look at it the same way we looked at the polynomial functions. As you go from quadrant 2 to quadrant 1 decreasing, or quadrant, the other graphs were quadrant 2 to quadrant 1 increasing, right? So they're actually both going from quadrant 2 to quadrant 1. Just if c is greater than 1, they're increasing. And if c is less than 1, then they're decreasing. So just summarize this last bit, and we're done. As the value of the base decreases, the graph gets steeper. Well, decreasing means it's going from a half. Let's go back. So decreasing is going this way, yeah. So it's getting steeper to the left, though, right? Like
Oh, that's what I meant.
I keep doing that. I want it to go this way. Steeper to the left. For 1/2 x, every increase of 1 unit, so every time x goes up by 1, what happens to the y value? it gets cut in half, right? Or decreasing by 50%. So it's going half. We go from 1 to 2, we go from a half to a quarter. And for 1/4, it gets cut. By 1/4. Decreases by, so what percent decrease are we going to here? So we go from 16 to 4, it's not a 25% decrease, it's a 75% decrease, right? Okay, yeah, and that'll play in. For all of these exponential functions, the domain is x belongs to the reals, and the range is that y is greater than 0. Okay, you can't be equal to 0, right? We can never get it small enough to be 0. The y-intercept is 1, so when x is 0, y is equal to 1, and there is no x-intercept. The graph has a horizontal asymptote with the equation. The equation is just the equation of the x-axis, so that's y is equal to 0. If c is greater than 1, the shape of the graph is like this. As you read from left to right, the graph of y equals c to the x is increasing. And the graph gets steeper as the value of c increases. We call this a growth function, right? In other words, it's growing. As you're going up, it's growing, it's getting larger. Here, I can probably make this bigger. If c is between 0 and 1, the shape is doing this. As you read from left to right, the graph is decreasing. And the graph gets steeper as the value of c decreases.
Why is it 75% if it goes down to 42 and 21?
No, it's going 16 to 4. We're doing the 4 to the
Yeah,
x. Oh, remember, it's each decrease of 1, so you gotta watch it, because in that table, there's like, there's a half in there. So we wanna skip over that half.
Yeah.
So when you think of the decreasing, just think of something being on sale. You're gonna buy something and it's 25% off. And don't think of it as it's 25% off. Think of it as what percent of the original price do I have to pay? And so I gotta pay 75%.